Graduate Center. Her research on how children learn language supports theories of innate grammatical knowledge, particularly linguistic universals, and investigates the interaction of linguistic knowledge and higher cognitive processing. Her work has potential implications for AI, particularly how LLMs are trained, how they generalize from training data, and their ability to represent variation and variability in language acquisition. In other words, just about everything that we're interested in this summer school. With that, I hand it over to Virginia.
Very much. I'm delighted to be here. What and how do children learn? It's adorable infants, all of whom come from different languages. And by the way, this is unfortunately the only attractive slide that I have. I'm going to start by giving you some examples of things that children say perhaps earlier than we think typically that they're able to. And this is work with Lilith Mosesian and Martin Chatterow. Here are some utterances from the Providence corpus of two children, Ethan and Naima, at 16 and 17 months. So these are their trigrams.
Virginia, sorry to interrupt you. You're showing your presenter notes rather than your main. You want all this to appear, what you see on the screen?
So I thought you would not see my presenter notes because generally it works fine.
Okay, I mean, it doesn't, I don't think it bothers us. It'll be duplicated. Is there anything on either of them that you want to censor?
Not to the best of my knowledge,
okay.
but I'm trying to think whether, so it's probably, maybe it's a problem because of my dual window. Let me see if well, I don't know. Okay, so maybe what I'll do is get out of presenter mode because I don't really. Okay. That's not gonna work.
The inverse of presenter mode.
What are you saying now? Just out of curiosity.
You chose the wrong window for sharing. There's something on your desktop that you should have chosen rather than this one.
So you should cut the sharing.
Cut the sharing.
Yeah, and reshare.
And select the window at the.
Oh, okay. Okay, got it.
Choose
Let me
the
see
right window to
if I can do that. And now share screen.
Now look carefully at what's on your screen. Make sure that that's really what you want to share.
Let's try this one and see if that works. Okay, so what are you seeing now?
I see Lilith and Martin.
Okay. Are you seeing them full screen or not?
Yeah.
Yeah, we have to go into presentation.
Go into presenter mode and see if it helps.
I'm trying to, but it won't go for some reason. Okay, I'm going to stop sharing again and I'll try a different. That again. Okay, let's try this one. Okay, what are you seeing now?
Got it.
Good. Now switch to the next screen. I mean the next slide. Okay, you got it.
Okay, so you're seeing my full screen and not presenter mode, is that right? Okay. So to continue, here are some sentences utterances from children aged 16 and 17 months, trigrams, and a few tetragrams. So these look very language-like. This is work that we've just started doing. But they also produce things like this that don't look very structured. Here's another set of utterances. I want you to look at those and mentally compare them to the utterances you just saw. These are utterances from chimps, and I think they look pretty different. And part of the challenge is going to be figuring out how to compare them with what the children that I've shown you here are doing. Our first crude analysis is to separate utterances where each word is different, utterances where there's repetition of a word. And we do that for both trigrams and tetragrams. And what you can see is that there's a steady increase in the percentage of all of children's trigrams and all of their tetragrams in the extent to which they are structured in this rather crude sense. This is aggregated data from only 4 children. Most of the data are from 2 children, and there isn't a lot of data. That's partly manifesting the sparse data problem that we have in general with children's early syntax. But I wanted to give you a feel for what are children saying, even very early, even before their 2nd birthday. There are a lot of issues in language development, and I'm only going to touch on some of them, but I hope you'll see why language acquisition is such a wonderful field, because it engages so many important questions. So one of the first questions is what we want to understand. I think we want to understand the mental representation of language, as well as the child's productions over time and how those productions change by context, and their comprehension over time and by context. A related set of questions is what counts as an explanation? How do we evaluate multiple models, all of which might predict production and comprehension, but say very different things about what the mental representation is? Part of a broader question, which is, when is a model an explanation? I don't have an answer. I want to present it as a question. Here's my outline of what an acquisition model looks like. There's some statement that we have to make about the initial state, about input, about the mechanism that they both feed into, and about the final state. This outline is very similar to what's called the norm of reaction in biology, where there's a genotype and an environment that works on an internal mechanism, and the result is phenotypic expressions. So a genotype doesn't specify a unique outcome of development, but rather a norm of reaction, a pattern of different developmental outcomes in different environments. So the import of this is you can have a genotype. That doesn't mean that all of the phenotypes that result from that genotype are going to be the same. So our acquisition model is parallel to that genotype model. And one of the that not everyone will converge on exactly the same grammar, even if the initial state is the same. There are varieties of final states that are possible. Let's turn now to what the poverty of the stimulus argument is, which came up in the earlier talk. So this is an argument of the form, the data underdetermine the theory. So it's just a special form of a much more general argument in the philosophy of science, which is, in general, the data underdetermine the theory. The principle to the child, the input to the child, according to the poverty of the stimulus argument, is in principle incapable of supporting the generalizations that they come to mentally represent. Things like syntactic categories, universal constraints on movement, and other syntactic properties. People could act as if they have categories without actually having them, just as LLMs can behave as if they have categories without actually having them. So the question that we care about is whether people do actually mentally represent syntactic concepts or whether they are LLMs. The poverty of the stimulus argument is not an argument about how noisy or ill-formed or degenerate the input is. This also came up in the previous talk. It's an argument about, in principle, insufficiency. And from it, generative linguists argue for nativism and universal grammar, commonly called UG in linguistic circles, is what's hypothesized to be innate. So what is UG? UG consists of the formal universals and the substantive universals. Universals are telling you what the formal structure that all languages are represented in, such as X-bar syntax, and substantive universals tell you what the content is, such as syntactic categories and features like determiners and tense, two things that I'm going to touch on today. So in modeling development, we can ask questions like, why are children's utterances so short at the very beginning? And from our point of view, it's because they have very limited higher cognition. In other words, children's reach, what they want to say, exceeds their grasp, what they actually can say. And as their resources expand, so will the length of their utterances. So this is a claim that children's early utterances are short in the way that you saw and leave things out, not because they don't know those things should be there, but because they are saving. So one way we can approach this is by looking at children's very, very early combinations. And a first question we can ask is there a two-word stage? There does seem to be a one-word stage, a period when children are only producing one-word utterances. But if children's reach exceeds their grasp, we shouldn't expect a two-word stage. We should expect that as soon as they start putting utterances together, they're able to put them together in varying lengths, but depending on what resources they have available, those lengths will vary. So how do children's utterances develop in length? This is work with Amber Hsu and Martin Chatterow that was published recently in Cognition. And we looked at the mix of different lengths over time, again, starting with the Providence corpus and other corpora that have children very early in development, earlier than most people think syntax is possible. So this is looking at age on the x-axis and the proportion of all utterances on the y-axis. So that top blue line that you can see, that's one-word utterances. They precipitously fall over the first few months, and then they level off. And what's a little harder to see is that utterances that are 2 words, 3 words, 4 words, and 5 words in length increase. And what's, again, hard to see from this is that the development looks discontinuous. And for all of these lines, segmented regressions provide a better fit than straight lines do. Nevertheless, we model development as a continuous development, which can result in what look like discontinuous breaks. So this model, which is due largely to Amber and Martin, not to me, is called virtual, and it has just two components. One component is varying resources that gradually increase over time. We're not specific about what those resources are. And an intent to model the target lengths that are in the adult input. So we imagine that at the very beginning, where the amber coloring is there, at the very beginning of acquisition and even later, depending on whatever might be happening in the situation, the child does not have resources that are sufficient to allow it to produce very many 3, 4, or 5-word utterances. But as development proceeds, so does the ability to produce more and more of these longer utterances. So we take the increase in length to be simply an increase in what resources the child has available. Okay, so here's a cleaned up version of the graph that you saw originally, and it again shows that apparent discontinuity where the data change their slope. What I want to draw your attention to are all of those dots. So those dots are individual children at each age point. Children are very variable. In part, that variability, that apparent variability may be more apparent than real. It may be because even when we have a lot of data, we don't really have very much data. And so utterances that are somewhat rare, for example, sentences in the passive, you're going to have a lot of data before you see them. And some of this variability, as I say, may not be real variability, but some of it probably is real variability. We have certain factual questions that we want to try to provide answers to empirically. Do children mentally represent syntactic categories and features? Are there empirical reasons to think that universal grammar is part of the child's initial state? How would we know? And if children do mentally represent syntax, does that representation occur before an LLM would have enough data to act as if it had syntax? I go further on that. I'm going to give you some of the issues in language development. As I said, these are things that let you see that language acquisition is at the center of the intellectual universe. So one question is the role of input. What role does experience play? Is the child completely data-driven? Is there a role for what Chomsky has called indirect negative evidence? What's the nature of the language learning mechanism? Here are 3 possibilities. Another issue is continuity. Is the child's initial system incommensurate with its later system, or is it the same system? And does the child have a system to begin with, or does the children have nothing? Does the child have nothing, which is later replaced by a system? Another set of issues that we need to take into account are that speaking and listening require integrating a number of different systems, each of which may be limited. So we're talking about syntax, but your ability to express your syntactic knowledge is dependent in part on all these other systems. And we want to understand how an acquisition theory of any one of these systems could accommodate possible limitations in the other. Another set of questions that I think we don't really have much of a handle on, in part because of silos and who looks at these, is when development proceeds differently, what's the difference and what's it due to? So there are early learners, children who seem to get everything right away. There are late learners who take longer. There are children with developmental language disorder, and so on. Are they doing something qualitatively different, quantitatively different? What's going on with them? Potentially, we can learn a lot about so-called typical acquisition by looking at all these other forms of acquisition. So let's return to the initial questions that I posed and compare two different approaches to acquisition. The first one is the one that my work has been taking, which is that children start with something that's very abstract, and what they learn are the details. This is a system that's an approach that's highly compatible with nativism, and it can be contrasted with what's sometimes called a usage-based approach, which is children acquire local details one by one, and they generalize. So this is a system that's highly compatible with empiricist theories and large language models. And that similarity has not escaped people. For example, Contreras-Collins et al. Say language models can be viewed as a usage-based answer to the poverty of the stimulus argument, at least when it comes to the production of grammatical knowledge. And I appreciate that caveat because it's making a distinction between what children produce and what they might have in their heads. And then they are mentioning 100 million tokens, or the first 10 years of a child's language exposure. But we can ask, how much speech do children hear by, say, 3 years? This is an estimate that Elika Bergelson, who with her colleagues has done a lot of work cross-linguistically on how much speech children hear. And her estimate is about 2.3 million adult utterances by age 3. And if we multiply that by 5 words, that's about 11.5 million words. And if we look at children who are 15 months old when they're starting to produce, they will have heard approximately 5 million words. There is enormous variability in the amount of speech different children hear. You can see from this, this is the number of adult words in a 10-hour day. And these are families with 19-month-old infants. And you can see that the speech that children hear varies from about 1,000 words a day, if we ignore overheard speech, to 10,000 words a day. So there's a great deal of difference in how much speech children are actually hearing. The Baby LM Challenge, which was such a terrific thing and is happening again this year, asked submitters to build models that either use 10 million words, 100 million words, or 100 million words plus anything else that they wanted to include. And they had a corpus that was built from various sources. Only 4% of it from the Childers corpus. That's because that's all Childers has. And they tested it on BLIMP and other tests. And strict small model was quite good. So it's making grammaticality judgments, basically. But that's in part because it had 2,000 epochs, which is not very plausible, as Morstadt et al. Bring out. However, a 15-month-old could not pass a BLIMP test or any of the other tests. So maybe none of that actually matters. I think what we want to model is children's knowledge and performance as it develops over time. And Udit's talk earlier also went into this. The second thing we want to model is interchild differences in acquisition, variability. And undoubtedly, the input will play a role in that, but it's not obviously the only role. This is a portrayal of the similarity as measured by the Marishta index, which is basically a cosine similarity index, in bigrams between children and their parents over time. So children are not most like their parents at the beginning. They become more like their parents over time. And you can see these lines are basically going up, but children vary a lot and their similarity varies a lot. Again, that could partly be just the vagaries of not having a lot of data. We don't know. But what I want to emphasize is that as far as we know, there is a lot of variability, and so we need to model that. The biggest challenge to large language models as a model of acquisition and as a challenge to poverty of the stimulus arguments is language without any input at all or with very limited input. So the existence of those data casts doubt on LLMs as a model of acquisition. And there are two sources here. One is Home Sign, work by Susan Golden Meadow and her colleagues, and the other is Nicaraguan Sign Language, work by Anne Sanghas and her colleagues, and a number of other people. Here's an example of an argument that Golden Meadow and her colleagues make about Home Sign. So a moment to tell you about Home Sign. Home Sign are gestures that deaf children in hearing households make in order to communicate with their interlocutors. In the case of Golden Meadows children, these deaf children are the children of hearing parents who do not want their children to learn sign language. They want their children to learn English. So these children are not getting access to any structured input, yet they are producing structured input. This is one example that Golden Meadow gives of what she's arguing is hierarchical structure early on, where the child uses both a sign for coin and a point to a coin to indicate that it belongs to the child. Another one, the child points at a train picture, then points to itself, and then points downstairs in order to say that the child's trains, David's trains, are downstairs. She uses that to argue for hierarchical structure. Obviously, these children do not have anything that looks like a full language. The question is, are the fragments that the child has things that we would want to call syntactic? Nicaraguan Sign Language is the creation of a new language in successive stages in Nicaragua. After the revolution, deaf children who heretofore had not had any education were brought together into a school where they could learn. They were taught in Spanish visually, and they were allowed to speak however they wanted to each other. And so the first cohort of children came with their own home signs and then shared those signs and developed a rudimentary system. Successive cohorts became more and more expressive, even though the input that they were presented with was not fully grammatical input. There were various things that it could not express. And the successive cohorts became more and more language-like. So this is an example from one of Senghas's papers. The upper picture shows a hearing person who's asked to tell a story about a cat which has swallowed a bowling ball and is going rapidly down a steep street in a wobbling, rolling manner. So the critical thing here is that the hearing person, whatever his words are, in describing it, has a gesture that is both indicating the manner of the movement, the rolling, wobbly manner, and the path or direction of the movement. In general, languages don't do that. Verbs express path or manner, but not both simultaneously. The earliest cohorts, and you see in this graph on the left, you see the extent to which people are using simultaneous manner and path in their productions. The gesturers always use simultaneous manner and path. Cohort 1 uses manner and path simultaneously 70% of the time, but by cohort 2, we're down to 30 and 40% of the time. So among those cohorts, it doesn't completely go out, but they become more and more like without having any input that would suggest to them that they should separate manner and path. All right, so that's a kind of general picture where I think the challenge for large language models is evident. The question I'm going to raise now is whether there's empirical evidence for more specific detail in the initial state. So the earlier the demonstrated existence of a syntactic category, the more constraints are put on learning theories. It's not a proof, but using the same terminology that Ronnie Katzer used yesterday, it's an inference to the best explanation. And I'll use two case studies, determiners and subjects. And let me say right off the bat that my wonderful collaborators do not necessarily agree with me about what the best explanation we can infer is. All right, let's try to answer before we start, what's innate if determiners are innate? My claim is it's an underspecified representation, and here's the form it takes. So this is what I'm supposing is the content that the child brings to the language learning situation about determiners. Determiners, phrases can have specifiers. There's a D bar level, and that goes to a head, and those heads take noun phrases as their complements. What you learn about determiners is a huge amount. You learn what lexical items make up the determiner equivalence class. That can vary cross-linguistically. I don't know if you can hear the siren in the New York City background. You learn a determiner. For example, in the United States, we say watch TV. In Britain, you might say watch the telly. You learn which determiner to use. So you shift from A to V in discourse. You learn what features the determiners in your language mark. So you learn a whole hell of a lot, but all of these things that you're learning are details. You're not learning the concept determiner by hypothesis. Okay, so here's a set of determiners in English, and the evidence that determiners are initially underspecified, I'm going to very, very rapidly review this, is both phonetic, morphological, and filler syllables. So early on, the is not distinguished from ka in children's representations. It seems all they've represented about the determiner is the schwa syllable. They don't detect gender differences early on. And in French, for example, children use filler syllables instead of determiners in the places where those determiners belong. For an equivalence class comes from Rushen Shi and her colleagues. For example, children who are trained on a real French determiner and a nonce noun generalize from the determiner they're trained on to another determiner, other determiners, and they don't generalize to a pronoun. We also can adduce non-syntactic reasons for omission. There's initial reliance on a prosodic template. Both Gherkin and Demuth have independently suggested this, that English has a trochaic template. This is slightly at odds with what Udit was presenting earlier. And so they leave off initial determiners, for example, because it doesn't fit a trochaic template. Also, children have relatively few determiners under their belt very early, and we know they have fewer attentional resources to bring to bear. So there are a lot of reasons that children might not include them. All right, what do children in fact do? Early work on this was with Stephanie Solt and John Stewart. Current work is with Charles Young, and Charles also did earlier work that particularly took into account the zip distribution and thought about the implications of that for children's productions. So here's, and I'm indebted to Charles for this slide, which you might recognize. So one way that you can approach the question of whether children have determiners is how generally they apply their rules. So it could be that children just applied the to cat and car and just applied a to boy, dog, and chair, in which case we would not want to say that they had a category because those two words were not sharing privileges of occurrence. But if children are in fact using them in all those situations where they're possible, then we would want to say that they have a category. So Pine and his colleagues, Pine's a usage-based theorist and investigator, developed a measure they called overlap, and that was the number of nouns that are used with both the and a divided by the number of nouns used with either the or a. So is the child restricted in how it uses determiners, or does the child use both the and a to the same extent that their parent does? So in recent work that Charles and I have done, we've looked at the Manchester corpus on childas. Earlier work with Solt and Stewart looked at the Valian corpus. These are 12 children Valian corpus was 21 children. Valian corpus was cross-sectional. This corpus is longitudinal, and we're talking about 2-year-olds. The important thing to see here, on the x-axis, we have the number of times that a noun is used with a determiner. So we're looking at all the child's speech, all the mother's speech, and we're asking for each noun, how often is it used with a determiner? And we're then stratifying our overlap measurement by the number of times a noun is used with a determiner. And what you can see is the more times you use a noun with a determiner for both mother and child, the more times you see overlap. So the conclusion that we draw from this is that overlap, perceived, observed overlap, is a function of opportunity to observe it. Charles has developed a different method in which you do not compare the child and the parent, rather you compare a predicted value, and that's what's in the red column, and you compare the predicted value to the observed value. And you do that for both the mother and the child, and you see to ask whether each of them reaches the benchmark that is given by the formula. And the answer, again, for these same 12 children, this time, I won't go into the methodological details. The answer is yes. So do 2-year-olds represent determiners abstractly? Yes, in the sense that they show overlap. I haven't shown you the data, but they do seem to be free from formulae. I also haven't shown you a lot of the data, but they also seem to be faithful to distributional regularities. That is, they put these determiners in all and only right places. There is, again, a sparse data problem, but from what we can see, children hit the benchmarks. So what develops over time is the number of determiner types and the frequency of determiner use. But, and here's where Charles and I differ, I want to conclude from that all of the data are compatible with an innate thin abstract representation to which the child adds details upon exposure to language. And the challenge for other frameworks is to account for the same data in the same amount of time. So if you buy the idea that children have a full-fledged determiner category by age 2, and that you do not see any hint of discontinuity development, how do you account for it? The second case study I will very briefly review has to do with sentence subjects. There are what we can call non-null subject languages. Those are subjects, those are utterances, those are languages like English and French, where subjects are required in all tenses and persons. There are null subject languages where subjects are never required, except, for example, in Italian, if the subordinate clause switches the subject compared to the matrix clause. But as far as matrix clauses are concerned, you never have to have a subject. And there are mixed subject sentences like Hebrew, where in the defective present tense, you always need a subject, but in third person and in past and future only. So subjects are optional in first and second person and past and future tense. They're only obligatory in third. So how do children learn this, and what does their development look like? Obviously, whether or not you have subjects can't be innate, but tense could be. And one reason for it to be innate is that it's involved in many syntactic phenomena, including the distribution of subjects. It's also present very early in children's English grammar, according to comprehension experiments that we've done. This is work with Martin Chodorow and Cindy Chen. And what we've done is develop a psycholinguistic extension of the Barrère-Chomsky conjecture. To simplify, we are hypothesizing that the overt presence of the inflection elements that control the distribution of subjects has psycholinguistic reflexes. The overt presence of inflection reminds English speakers that subjects are necessary in their language. So what we predict is that both adults and children will be more likely to include a subject when their inflection node is overtly filled with either third person singular present tense, past tense, auxiliary be or have, or modals, compared to bare verbs, verbs that have no inflection on them. Here are the data. I'm only here presenting the data excluding possible imperatives. So undoubtedly, some of the things that we excluded aren't imperatives, but especially with the child data, it's very hard to know what's an imperative and what isn't an imperative. If you look on the right at the adult data to start with, you can see that the red box and whisker is how often adults provide subjects for bare verbs compared to the kind of muddy green bar, which is how often they provide them when there's a modal and auxiliary, and the purple bar, how often they provide them with tense. So adults do not uniformly provide subjects. They provide them more when their utterances are overtly tense. The teal bar is an example of cases where we thought we shouldn't see more subjects than with bare verbs. And those are so-called semi-auxes, things like gotta go. You can see there's tremendous variability there. If anything, subjects are used even less there. We go to the left-hand side now, and you look at the child. And again, these are children from the Manchester corpus, 12 children, 34 sessions. You can see that the pattern is qualitatively similar, although quantitatively different. The children provide fewer subjects overall, which we argue is due to performance reasons. And they distinguish between utterances that are overtly tensed, either with tense or with modal and auxiliary, compared to bare verbs. Oh, English-speaking children leave the subject out about 30% of the time. Our conclusion is they know that it's required. So we're concluding that by age 2, children know what kind of language they're in. How can language models help? They can help us model development. They can help us model variability in development, and they can help us model early outputs. I now turn it over to you and others for comments. Thank you.
Well, no introduction is needed for our first designated discussant.
Right. Yes. So thank you so much, Virginia. This really, I think, sort of made a fantastic overview of different aspects of development. So today we saw very different things, and especially provided a lot of actual input and actual data on what real kids do. And so, yes, I think this is very important to have kind of the sort of the boundary conditions clear, right? This is what we are aiming to model. So I was very happy to see that. It's very hard to come up with comments for a talk where I agree with virtually everything. So, one thing.
Agreement is awful. It destroys all discourse.
Yeah, no, right. But so like one thing I would like to maybe emphasize, and then see what others think, or even Virginia herself, is exactly what you concluded in a certain sense, just very briefly, namely, it's relatively easy to model what kids get right. I think the challenge is to model how they get things wrong, because it's not random. And I think that's kind of the take-home message for me, at least, from these very early productions. That is, they are not adult-like, they are not fully target-like. At the same time, it's not a mess. They're not all over the place. They do seem to show very systematic ways in which they meet the targets and systematic ways in which they don't. So this, I think, for me is kind of the take-home message. And that's almost more challenging to get, to model than full-blown competence, because, you can get there in many different ways. But to get it wrong, well, and wrong in the correct way, that's kind of tricky. So I still have one question and one brief comment. And so that my question was, is whether there was a how to say, a conscious choice why you decided to look at the acquisition and sort of the abstractness of the representations of determiners and subjects. I guess subjects are easier to understand because they're just such a massive category, right? So even
Yes.
in all
Yeah.
subject languages, that we assume that underlyingly there is still some kind of grammatical form. So we could spell out the subject. Even if it's not there, we could sort of spell it out somehow. But determiners seem like, well, they're functors, so they are challenging and harder. And of course, the semantics is less clear, but they are more frequent. At the same time, they are cross-linguistically extremely variable. So I thought this was a really interesting choice, but I wonder why you made that choice. And then maybe I'll let you answer this, and I'll just come back with a small comment.
Okay, sure. I chose determiners exactly because they don't have clear reference. So if we want to understand how does a child get nouns, we can do the kind of semantic bootstrapping that Pinker and others have suggested. But if we want to understand determiners, it's more challenging to come up with an alternate explanation than syntax. I was also very intrigued by Pine and Martindale's, and then Pine and Levin's use of the overlap criterion. And I think of them as wonderful adversaries because they always think the child knows nothing, and they have clever ways of trying to demonstrate that the child doesn't know anything. So they're a big challenge. And Pine and Martindale's initial paper was a challenge to a paper I had written looking at categories, nouns, prepositions, determiners, noun phrases, prepositional phrases, and using distributional regularities to argue for them. And they criticized that, saying, well, the child could just say the ball, and you're going to give the child credit for having a noun phrase and nouns and determiners, but you need something that's much more rigorous. So that initial paper then, which was on determiners, then prompted me and these two students who were in my language acquisition class to look more thoroughly at just determiners. And I think that they're a good choice.
And so did you by any chance look at other languages? So say French comes to mind where determiners are almost always present, right? So bare nouns are very rare in French. Or you could pick, say, Russian or a Slavic language where there are no articles, and so they are overall, the category is less frequent. So I wonder what
Yeah,
that.
so no, and I would love to look at other languages and that also gets into a question that people have raised about, do you really want to say that all categories are innate, given that, for example, Chinese does not have articles, Russian doesn't use them. So I think there are two answers to that. One is all languages, to the best of my knowledge, have demonstratives as determiners.
Yeah.
And so that is enough to settle that. But the larger answer is, I don't think it's the case that every category needs to be instantiated. So on the way I'm looking at it, child's going to look, what do I have that might be a determiner? And if it doesn't find it, it would say, oh, okay, I guess I don't have to worry about that here. That's one way the child could go about it. So I think it would be interesting, especially to look at languages like Italian, where possessive pronouns seem more to be adjectives than determiners, because you can say the, my in Italian, which you can't say in English. So what I have no idea what children in Italian are doing early
on. So I'm gonna just now sort of make a small comment, but I think it was very relevant, as you yourself mentioned it in the talk about sort of the trochaic iambic nature of English. And I think, yeah, right. So I think essentially we're talking about different levels. And so this is why, so English is strongly trochaic at the level of sort of the words, especially nouns or sort of clitic groups. What would be clitic groups in other languages? Whereas I think the prosody I'm talking about is at sort of much larger levels. So prosodic phrases or something. So I don't think the two are in contradiction actually, but just are different levels. And definitely infants are sensitive, even young infants, right? So Peter Jusik's work showed it very nicely that at 7, 8, 9 month English exposed infants are sensitive to the word level, and so we know from other work that they're sensitive to both levels. So I think actually these explanations are compatible, and I definitely think that prosody has a lot to do with a lot of the performance issues or the sort of resource issues that that you're mentioning. And I think that takes us to my maybe final question comment about modeling these resource problems. So I think, of course, it's everybody's dream to come up with something like a large language model, which also has memory and attention and, you know, all those things that we call resources, or you called here resources. But I was just wondering what modeling approach you would take. So what are the things that you would necessarily implement or you would like to see implemented to be able to actually test this idea on a model? Because I think your data was very convincing at the empirical level or sort of a child production level. But what would a model be like minimally to actually model this dependence on the child's knowledge or the expression of the child's knowledge on other resources? So what are the resources that you would like to see modeled?
I think there are two ways of going about it. One is the way that we went about it in the growth of utterance length, which is we didn't try to specify what all the different resources were. We just said, there's a bundle of resources. Some of them are linguistic, some of them are cognitive, and we're just going to posit that they vary. They vary moment to moment, and they vary over time. So over time, they vary somewhat systematically. They grow from moment to moment. They vary in ways that we probably just can't explain.
Yeah.
And you'll see these stretches in transcripts where the child says, want lollipop, want a lollipop, mommy, a lollipop, I want a lollipop. The child has all these different variants of the utterance, almost right in a row, and we attribute that to varying resources. So just as I wouldn't plan to track the trajectory of a leaf falling from a tree in all of its movements, but I would want to say wind, weight of the leaf, etc. All of those together are going to have an effect on how fast that leaf falls. So I like the idea of really simple, where I have some idea of what's going on. I like the idea of having a model that has as few moving parts in it as possible. That doesn't mean it's the right way to go or a good way to go, but it would be my preference to have a model that I could actually understand.
Thank you so much. Thanks a lot. I don't know if others have.
Julia, can you turn on your mic? That's it.
Hey, thanks. Awesome talk, as all the talks have been so far. But I was just wondering, so Ray, the last slide where you were kind of going through how could LLMs be helpful, you had mentioned, you know, there's these places where you don't have enough child output data. Could maybe an LLM be used to augment that corpus of data? I mean, there's obviously ways that could go horribly awry, but do you think there are ways that could go right?
That's an interesting idea. I don't know, because of the sparse data problem. So there are some, like negation, for example. There aren't that many negatives in children's output. So you're often dealing with aggregated data across a bunch of children. So I'm not sure on what basis you would know how to project a structure that you didn't see, because it could be there. It's just you don't see it. And so I don't know on what basis you would be able to project. Now, one thing I'm thinking of has to do with the passive, which I didn't talk about. Children hear almost, especially full passives, like the mountain was climbed by the mountaineer. Those are just almost absent, it appears, from child speech. And what kind of representation you think the child has, and whether you think the child can map flexibly between thematic roles and syntactic relations, you might be able to test what the child would do in a priming task, for example. So I'm using that because Julia Vancini and I did do a priming study on the passive. So you might be able to predict that a child would show more priming, say, of the passive in an experimental situation based on evidence that you might have that the child could flexibly map thematic roles and syntactic relations. That's different from what you're suggesting, and maybe other people have thoughts about that. I don't quite see how it would happen. Were you suggesting it because you hadn't about how it would happen?
No.
Okay. Thanks.
Okay, I'd like to, I don't want to preempt the panel tonight, where as many of the people here will be in the panel. I wanted to just do a little sondage. Ronnie, are you in such agreement with all of everything that's being said here that you have nothing negative or critical to say?
Yes, I'm very much in agreement, and I have nothing negative to say.
Okay, that's too bad.
Yeah.
Think about something before tonight.
But my
okay,
co-author, Charles, might have things to say. Charles's hand was up.
I signaled him too. All right, you
Okay.
go ahead. But don't preempt the panel either. If there's something you've already prepared for the panel, then just hold it for the panel.
I just have a quick comment in response, I think, to Julia's question of using large language models to generate or as a substitute for child data. I actually tried that the other day. I paid for the ChatGPT API. I said, pretend you were talking as a child, and I piped in the sequences of mother's data from childless to the model and asking it to generate responses. The results are quite comical. I don't know if people want to see it, or I can show it tomorrow.
Okay, that's interesting because I did a slightly similar thing. I gave ChatGPT 2 different child utterances, and I asked it which one was better, but which for me would mean more faithful to things that children do. And it was not able to do it. It just kept saying, that's ungrammatical. But I didn't feed it actual child utterances. I just asked it, I gave it minimal pairs basically, and asked it which one is better. And it had no idea.
Well, I can show it tomorrow, but you'll be amused. And the answer is certainly you cannot substitute actual child data by machine generated text.
Okay, what about Friedemann? Well, Friedemann has had to say. Do you have something you want to say now?
Well, there are of course many things to mention, but I think one thing I could briefly say is that it has been argued recently that any positive evidence might be evidence for for combinations involving the uttered elements, but in different contexts, and it's negative evidence about those. So if I use the word sequence AB, this is also evidence that the sequence AC is unlikely or actually doesn't occur on this instance.
Yes, so Vaughn and his colleagues have a really interesting paper in which they try to model word learning in an infant who's wearing a camera. And the model uses contrast, which I think what you're suggesting implicitly uses. So it looks at where the equivalent of AB is used and where AC isn't used. So it's a form of indirect negative evidence, but I think AB by itself is not evidence against AC. It's it's neutral with respect to AC.
But your this claim of yours is wrong from a biological point of view.
Okay,
We
say
know
more.
that at the biological level, learning works like this. If two things occur together, there's this famous rule of what wires together, what fires together, wires together. This is the old rule Donald Hebb has created or has found out about about a zillion of years ago. But at the same time, we now know that whenever two things do not activate together, two neurons actually, then we have a weakening of the link. So whenever we hear AB, it's indeed biologically correct that any link between A and C that might be there would weaken. This means that my construction AB would preempt the construction AC.
Okay, however, if that were the case, then children could never learn to say both a computer and a machine and a glass and so on, which they do. So you've got A with a whole bunch of different things. You don't have A with a verb. You only have A with a bunch of nouns. So depending on the level at which you're characterizing A and B, if you're characterizing them at the token level, I think what you're saying is wrong. If you want to characterize them even at a more abstract level, there's going to be a problem because you can have determinants or adjectives or before nouns, and all of those things are part of language.
Well, I think this only applies if you consider each noun as a separate representation, and you assume that the link that needs to happen is between A, the article, and B, the individual noun. However, the link might indeed exist at the level of lexical categories, in which case the biological problem does not occur.
But as I just said, A can also go in front of adjectives, and we don't have a problem with that. And it can go in front of multiple adjectives. So I think what you're saying is not going to work when we're in the domain of linguistics. And I think what you're saying also nudges a problem that people have called the subset problem, which is that any given hypothesis might be compatible with a lot of other hypotheses. And without negative evidence, it's very hard for you to rule out those other hypotheses. So I would say, I think you're taking the analogy to the brain more directly than anything we know about language would allow us to do. But I notice in what you're saying that you're using categories, and I think that's great.
Well, yeah, that's a case for the general discussion tomorrow. I would still say that the language is based on mechanisms that are immanent to the brain. Therefore, if we think about language, we are very well advised to think about the real mechanisms that realize language.
By the way, the panel I'm talking about is not tomorrow. It's today. In fact, it's the next.
Oh, yeah, right. So only in an hour, in half an hour.
Yes, and could I make a suggestion for this panel? The two things. Number one, could I ask you please to the panelists to turn on your faces throughout? Because I think for people who are watching it, they have a much better idea of what's going on if they see the facial expressions and the faces and not just occasionally see them pop up this evening. And an even bigger challenge to you than to show your face is to bear in mind that I'm just going to make up I'm going to make up the figures intuitively, but I think I'm probably close. I would say the attendance and the speakership, and perhaps also the registrationship, which is bigger, of this summer school, is 20 to at most 25% linguists. That's less than a quarter. They're very important, and they've been forefronted with intention by me and by the rest of you. But the challenge now is this evening for the panel, could you please don't just speak to one another and assume that the special aspect of your topic is the only one of interest or the main one of interest to the summer school. You can talk about it, but please put on your pedagogical hats and consider that there are 75% non-linguists present as well. Now, this is not a criticism. I really do feel that although you're only 25%, what you've been saying over here is much more relevant than most of the people here yet understand. But you're saying it in the context of your own home territory. And I ask that in the panel, you say it in the global village context, if I can borrow Susan Schneider's metaphor in part. So that everybody appreciates why it is that what you're saying is important, not just to linguists, but to the question of what large language models learn and what large language models do or don't understand. It sounds like a sermon, and I have a feeling it's going to be followed by silence. Do you have any? Okay, thanks. So we're almost finished here. If there's no more questions, I don't want to force them on anybody. Let's take a break until this panel, and that'll give you a chance to think over how to present this for the rest of the world. Okay.